Good day viewers, I welcome you all to this additional mathematics presentation. So I want us to answer this question that is coming from trigonometric identities. So this question came in additional mathematics paper 2 for 2023 for internal candidates, specifically question 6. So prove the identity. We have 2 over cos power 4 theta minus sine power 4 theta plus 1 is equal to sec squared theta. So we are going to write our question, that is step 1. So this is our question, 2 divided by cos power 4 theta, then minus sine power 4 theta, then plus 1. So they are saying this is equal to sec squared theta. Now, when you are proving trigonometric identities, you can see that we have two sides. We have the left hand side and the right hand side. So you can either prove that the left hand side is equal to the right hand side, whatever way. Now you need to find the easiest one. So the easiest one here, we can use the left hand side to prove the right hand side. So we are going to use this one to prove this right hand side. So now on the left hand side, what do we have? So you can see we have 2, then we have we have cos power 4 theta minus sine power 4 theta plus 1. So this is what is on the left hand side. So from here, what are we going to do? So take note at the denominator, you take a look. So I will draw you back to the principles of the difference of two squares. So if you have a squared minus b squared, this you can write as a minus b in brackets. Again, you can write as a plus b. Now in this case, when you see we have cos power 4 theta minus sine power 4 theta, so just this part, okay, we can write it as since we have cos power 4 theta, then minus sine power 4 theta. So just this part alone, we can write it as cos squared theta minus sine squared theta in brackets. Again, cos squared theta plus sine squared theta, such that when we expand this, we are going to get this, which is this part right here. So we are just going to write this part. So we are going to write 2, then we write cos squared theta minus sine squared theta in brackets. Again, we open the brackets, we say cos squared theta plus sine squared theta, okay, then plus 1. So from here now, what is next? So from here, what is next is that we need to be aware of the general trigonometric identity, which is this one. So we know that we have a trigonometric identity, which is cos squared theta plus sine squared theta equal to 1. We have this trigonometric identity. So you can see here we have cos squared theta plus sine squared theta. So this means it's equal to a 1. Okay, so here we put a 1. Okay, that's our next step. So from here, this is what we are going to do. So we are going to write 2, then we write cos squared theta minus sine squared theta. So this is a 1. Okay, so this is a 1, then plus a 1. So this means that this one will multiply this. You get cos squared theta minus sine squared theta plus 1, because this one has multiplied with everything inside the what? The brackets. So this is what we are going to have. We have 2 over cos squared theta minus sine squared theta in brackets, then plus 1. Now, from here again, what are we going to do? So from this stage, we can see we have cos squared theta minus sine squared theta. So we are going to substitute, we are going to replace where we have sine squared theta by looking at this trigonometric identity again. We'll make sine squared theta the subject of the formula, meaning that it will be sine squared theta equal to 1 minus cos squared theta. So I've just taken this cos squared theta to the right hand side so that we have sine squared theta as the subject of the formula. So here where we have this sine squared theta, we are going to put 1 minus cos squared theta. Okay, so that is what we are going to do. So let's do it. So we have said we have 2 over, so you write your cos squared theta minus, so where there is sine squared theta, we'll put 1 minus cos squared theta. Now we need to put it in brackets because of the minus this one. So we say 1 minus cos squared theta, like this, then plus 1, this one here. So we can move on. So from here we can open the brackets where we say 2 over cos squared theta. So 1 negative times positive 1 will get negative 1. Negative times the negative will get a positive. Then cos squared theta plus 1. So from here we can notice that negative 1 and positive 1, these will cancel. Negative 1 plus 1 is a 0. To cancel. Okay, so we are just remaining with 2 divided by, so cos squared theta plus cos squared theta, this will give us 2 cos squared theta. So from here we can notice here there is a 2, there is a 2 here 1, 2 here, it's a 1. So what do we remain with? 1 over cos squared theta. So now this that we have, it's a reciprocal of what? Sec. Okay, it's a reciprocal of sec. Now because of the squared here, so it's a reciprocal of sec squared. So 1 over cos squared is the reciprocal of sec squared theta. Okay, and you can see this that we have, indeed it is equal to the right hand side, which is also equal to sec squared theta. So you can say hence proven. Okay, hence proven. So this is how we can prove this trigonometric identities. So remember in the exam it was carrying 4 marks, so you need to prove it in this way. So remember there are different ways that you can use to prove this trigonometric identity. If you want, you can use this method I've shown you, or there is another method that you can use. Okay, so we have come to the end of our short presentation. Thank you so much everybody. This has been your presenter, Mr. Mlenga. Bye bye.